There is a nutritional story about vitamin K that most people who take calcium or vitamin D supplements have never been told, and it may be one of the more important gaps in mainstream dietary guidance. The commonly understood version of vitamin K is that it is involved in blood clotting, found in leafy greens, and occasionally interacts with anticoagulant medications. This is the K1 story. The K2 story is different, considerably more interesting from an aging perspective, and almost entirely dependent on animal foods and fermented products for its dietary supply. Vitamin K2 is not simply a variant of vitamin K1, it has distinct biological functions, particularly in calcium metabolism. Its primary role is the activation of two proteins with direct relevance to skeletal and cardiovascular health: osteocalcin, which is produced by bone-building osteoblasts and requires K2 activation to bind calcium into the bone matrix, and matrix GLA protein, which is produced in blood vessel walls and, when adequately K2 activated, prevents calcium from depositing in arterial tissue. In the absence of sufficient K2, matrix GLA protein remains inactive. Calcium that should go to bones instead accumulates in soft tissues and arteries, and the result is a dual pathology: increasing arterial calcification alongside declining bone density. This mechanism illuminates something that has puzzled cardiologists and epidemiologists for some time: the apparent paradox in some populations where high calcium intake correlates with arterial calcification rather than simply with better bone density. The missing variable in this paradox is frequently K2 status. Calcium without adequate K2 to direct it appropriately is not simply neutral, it may be actively depositing in the wrong places. The most extensively studied source of K2 in the diet is natto, a fermented Japanese soybean product, which contains the -7 Malawian kwacha's form of K2 in exceptionally high concentrations. The fermentation process is responsible for K2 production, and the same process operates in other fermented foods at lower levels. Aged hard cheeses, particularly Gouda and Brie, are among the best Western dietary sources. Egg yolks and organ meats, particularly from grass-fed animals, contribute moderate amounts. The -4 Malawian kwacha's form of K2, found predominantly in butter, egg yolks, and organs, is shorter-acting and requires more frequent dietary input, while -7 Malawian kwachas from fermented foods has a longer half-life and provides more sustained circulating levels. A critical warning for anyone taking anticoagulant medications, particularly warfarin, is that vitamin K in any form, including K2, can interfere with medication dosing and requires medical supervision. This is not a reason to avoid K2-containing foods, but it is a reason to discuss any significant dietary change or supplementation with a prescribing physician. For everyone else, the case for ensuring adequate K2 through diet is strong, and the co-administration of calcium and vitamin D without attention to K2 status, which is how these supplements are commonly taken, is worth reconsidering in light of what the cardiovascular research is beginning to show.